This is Iron Designer here, looking at a new engineering problem, this time involving a slugging wrench and the hammer. It is problem number 6.56 in the Professional Engineer's Handbook by McGraw-Hill, 2nd edition. The author is Lalonde. So in this problem, we're going to have a slugging wrench and a hammer strike. Now this is how the sketch looks. You have these slugging wrenches. They were used in the past quite a bit for tightening bolts, and a hammer used to strike the end of the wrench in order to make it tighter than the person could by simply turning the wrench with his own hand. So in this case, you're asked to determine the diameter of the slugging wrench, the rod diameter of the slugging wrench. The weight of the hammer is 5 pounds. That is striking the slugging wrench with a speed of 12 feet per second. And the length of the wrench is 18 inches long from the neck. The material of the wrench is 40,000 psi strength of the wrench material. The first equation we begin with is the kinetic energy equation. And the kinetic energy equation is 1/2 mv squared, where you have the mass is equal to the weight divided by gravity, 1/2 times the velocity of the impact squared. And it tells us that the moment of impact, the hammer is traveling at 12 feet per second. We also need to review the equations for potential energy. And in this case, the deflection of the rod of the wrench. The deflection is equal to PL cubed divided by 3EI. And we consider the slugging wrench to be like a cantilever beam with a force at the end at 18 inches long from the neck. The equations for the potential energy are given. It's the average mass squared times L divided by 6EI, where XX is about the x-axis through the center neck of the wrench. The average stress sustained by the wrench is squared times moment of inertia of the rod of the wrench times the length of the wrench divided by c squared, which is the distance from the neutral axis to the outer radius, times 6 times E. Solving for PE using that equation is stress squared times L divided by 6 times E divided by pi times D squared over 16. The deflection equation is FL cubed divided by 3EI, where I is equal to pi times D to the 4th divided by 64, and C is equal to the diameter of the rod divided by 2. The stress is equal to MC over I. This is the basic standard equation for stress in bending. The average mass is equal to the stress times the moment of inertia about the x-axis divided by c. The next equation is deriving the spring energy using the bending equation. So the spring energy in a bent cantilever rod is m squared I over 2EI. The equation to the right for the energy after integration is P squared L cubed divided by 6EI. And you'll remember that's the equation from the previous slide. In closing, the closing steps are repeating the basic information of the velocity 12 feet per second and the allowable stress of 40,000 psi. We've given the equation 1 again, and computing the values, you get a diameter of 2.07 inches diameter rod of the wrench. Just as an additional homework problem, you have the deflection is equal to PL cubed divided by 48 EI. I'm asking the student to solve the same derivation using this new beam deflection equation. So this has been Iron Designer. Thank you for another video. And if you like this content, please like, share, and subscribe, and give us a thumbs up. Put the bell icon so you get notifications when we get new videos out. And we'll be including more content such as this for students trying to pass the PE exam. And this is Iron Designer. We are out.